Assalamu alaikum, Dr. Wan. Today we're going to be talking about the examples on equilibrium of a particle, and we'll be focusing on example 3.9. So we are group 9. We consist of 5 members: Anas Ahmed Abdul Bagi, Nuri Rahayu Putri, Habil Gibran Nugrakka, Imran Shahriar, and Muhammad Al Zikrullah. So this example tells us to determine the tension in each cord used to support the 100 kg crate. So I'll show you the first steps. So as you can see here, we're first supposed to be drawing the free body diagram from the question. So we know that the mass is 100 kg and it's acting downwards, so we can draw that over here. And the mass is 100 kgs, and to find out the weight or the net force, we multiply the mass with gravitational constant g, which is 9.81, so the total downward weight becomes 981. So first we resolve all these forces into their three-dimensional components. So we're going to be starting with force B. So now force B only acts on the x-axis, so it does not act on the y or z axis, so that's why it has no 0g value, no 0k value, just only an FBI value. Then we're going to resolve FC using the first angle method. So there's the angle with the y-axis is 120 degrees. So the first thing we're going to put is FC cos 120i. And then the angle it makes with the y-axis is 135, so we're going to put FC cos 135j. And the angle it makes with the z-axis is 60, so we're going to put FC cos 60k. Okay? So if we solve the answer, we get minus 0.5i minus 0.707j plus 0.5k, all multiplied by FC. So next we resolve force D. So we're going to do this by the coordinate method. So we know that x is minus 1, y is 2, and z is 3. So if we square root all the squares of these values, you're going to get this value, okay? So if you divide each of the x, y, and z value by this value and multiply them with the I, j, and k, you're going to get the vector value, okay? In this case, the answer will come minus 1 by 3i plus 2 by 3j plus 2 by 3k multiplied by fd. And we're also going to add w is equal to minus 981k because it acts on the z-axis but only in a negative direction, similar to force B. So for everything to remain in equilibrium, all the forces when summed together have to be equal to 0, and all the forces components have to be equal to 0. So we are going to make 3 equations, one for each component, and we're going to be adding up the values of each component. For example, for the I values, we'll be taking the I values from force B, C, and D. So it will become FB minus half of FC minus 1/3 of FD is equal to 0. And for the next equation, we're going to be resolving all the j values. So because f of b has no j value, it's going to be 0. So it will be minus 0.707 fc plus 2 by 3 fd is equal to 0. And for the third equation, as I said, fb has no factor, so that's 0. So the final equation will be 0.5 fc plus 2 by 3 fd minus 981, like remember the weight is acting downwards, is equal to 0. We have our final 3 values. So we're going to be solving a simultaneous equation. So as we can see here that FC, the J and the K values have only 2 unknowns. So if we can take any one of them and put them in such a way that, say we take the second equation, the J value equation, we can rearrange it so that 0.707 FC is equal to 2 by 3 FD. So pretty much FD is going to be 1.0615 FC. So we have the value of FD, we could input it into the third equation. So basically, we'll only be dealing with FC. We'll only have one factor to deal with, and then we can solve the equation, and FC will come out as 813 newtons. So we have the value of FC, we plug it into the value of the J equation to find the value of FD. We solve that equation, and we get 862 newtons. Now that we have FC and FD, to find FB, we just plug these two values into equation 1, and we get FB. Thank you for taking your time to see this video, and I hope you like it.